Have you ever looked up at the night sky and wondered how those tiny, twinkling stars that are actually satellites stay up there? And the answer is a beautiful dance between speed and gravity. Now, you throw a baseball. It travels a short distance and then curves down, hitting the ground simply. Now, what if you throw it harder? It travels farther before it hits the ground. What if you could throw it incredibly hard? The Earth's surface curves away from it at the exact same rate. The ball is constantly falling. This, my friends, is what we call an orbit. That magical speed is called orbital velocity. For a satellite in low Earth orbit, about a couple hundred miles up, this speed is a blistering 17,500 miles per hour. That's like traveling from New York to Los Angeles in about 10 minutes. At this incredible speed, the satellite is perfectly balanced. It has enough sideways momentum to keep missing the Earth as it falls. In fact, the force of gravity on a satellite in low Earth orbit is almost as strong as it is here on the surface, about 90% as strong. That's why astronauts on the International Space Station experience weight. It's not because there's no gravity. It's because the station, and everything inside it are all in a constant state of freefall around the Earth. Just like our super-fast space, they are falling together, so they feel weightless relative to each other. So, how do we get satellites up to that speed in the first place? That's where rockets come in. A rocket's main job isn't just to go up, it's to go sideways really, really fast. When a rocket launches, it first goes straight up to get out of the thickest part of the atmosphere, which would slow it down. Then, it starts to tilt and fires its engines to accelerate horizontally, parallel to the Earth's surface. Once it reaches that precise orbital velocity of 17,500 miles per hour, the engine can shut off. The satellite is now in orbit and will stay there, coasting for a very long time. But what about satellites that are much farther away, like the ones that provide our GPS signals? They are in what's called a medium Earth orbit, thousands of miles up. Because gravity is weaker the farther you get from Earth, these satellites don't need to travel as fast to stay in orbit. Their orbital speed is a more leisurely 8,700 miles per hour. And then you have geostationary satellites, which are way out at about 22,000 miles. They travel at a speed that makes them take exactly 24 hours to complete one orbit, since the Earth also rotates once every 24 hours. These satellites appear to hang motionless in the sky from our perspective. This is super useful for things like communication and weather forecasting, as a satellite dish on the ground can just point to one fixed spot. So, there you have it. Satellites stay in orbit, not by fighting gravity, but by using it. They achieve a perfect harmony between their forward motion and the constant pull of Earth's gravity, essentially folding around the planet forever. It's a simple concept, but it's what allows us to have global communication, GPS, navigation, and amazing images of our beautiful world. Thanks so much for watching. If you enjoyed this and want to learn more about the wonders of space and science, don't forget to like this video and subscribe to the channel. See you in the next one.